So just recently, we discovered that an insect that eats our roses in autumn and in spring actually captures light to produce food in the same way that plants do. And just a few weeks ago, we all watched as NASA landed a roving laboratory on the surface of another planet, and it has a ray gun. You know, this is a universe full of wonders. In this universe, we have star nurseries, we have jets of light that cross the galaxy, we have cells that reproduce themselves by dividing themselves. And in this universe, you know, we're all fascinated by what happens in this universe. Where do we come from? How does it work? Where are we going? And we all feel this curiosity and wonder at some stage in our lives, usually as children. But this curiosity and wonder is what motivates scientists to find out where we came from and how things work and how we can solve problems. And it certainly motivated me to become a scientist. But you know, it really concerns me that people tend to see science as something that's a bit remote, that it can only be carried out by people in white lab coats with tremendous solemnity in some dank, dark lab somewhere with their crazy assistants, right? But I contend that this is not the case. I think that science is for everyone, and I think that we can all be a part of this experience. I think also that what we find from science, which is not just facts, what we learn from it, is something that we can apply in our everyday lives and that we do apply in our everyday lives. So I want to tell you how we can find curiosity, wonder, and scientific thought in our everyday lives. So I'm going to tell you a story. I want to tell you a story about dinosaurs. Okay, who doesn't love dinosaurs? Hands up if you don't love dinosaurs. No one? Good, because if you don't, you're first against the wall. Now, when we first, you see, human beings have had a very long relationship with dinosaurs. We've discovered their fossilised footprints and their fossilised bones for millennia. And we came up with many different explanations for what they were. And it's actually believed that finding dinosaur bones, giant femurs and skulls, are what led to our early beliefs in dragons and, for instance, griffins. The first person to use the word dinosaur was a man called Richard Owen. Now, let me set the scene for you. This was in 1842, I think. So Charles Darwin had released his theory of evolution. All these fossils were being found. It was a great age of Victorian science, of discovery, and the public was fossil mad, and they were fascinated by dinosaurs, as we are today. There are a lot of amateur fossil hunters, and a lot of great finds were actually made by these amateurs. And Thomas Huxley was the very first person to suggest that perhaps they weren't lizards, perhaps they were the very first birds. But this idea didn't really hold. We found giant Tyrannosaurus rexes and brachiosaurs and so on, and it was like, nah, they're big lizards. We'll stick with that. And who doesn't want to? I mean, they're like dragons, right? We all really want dragons in our lives. And at the same time, people were trying to grapple with the fact that human beings had arisen from primates, that life had evolved on Earth for millions and indeed billions of years. For the next 100 years, the public continued to be fascinated by dinosaurs. We didn't believe that they were birds. We continued to think that they were giant, sluggish lizards, that they weren't really too bright because their brains were pretty small in proportion to their body size. But we did accept that evolution is a mechanism for the generation of life on Earth and of new species. But in the 1970s, this began to change, and there's a bit of a dinosaur revival. We found many, many new fossils, and a man called John Ostrom was the first person to suggest that, you know what, I really think that dinosaurs are related to birds. And it's through looking at the anatomy and all of the new fossils that emerged that he came to this idea. Gradually, over time, we actually began to find small dinosaurs that appeared to have feathers. And the very first truly feathered dinosaur that we found was called Sinosauropteryx, and it was found in China. And it was found in the special formation called the Yixing Formation. And this year, we found the largest feathered dinosaur to date. It's called Upulie. This is the biggest feathered dinosaur that we've found so far. It's a relative of Tyrannosaurus rex. Think about it. T-Rex relatives are fuzzy. But we're finding more and more fossils, and this is what's amazing, all different sizes. And this particular one that you can see up here, it has a huge bushy tail. We now know that some dinosaur lineages, particularly the theropods, evolved into birds. And we can tell this partly because we now have fossils that show that these dinosaurs had feathers, or started out having feathers. But we also know that since birds have a very complex breathing system, they have lungs and air sacs, we found evidence for the presence of these air sacs in dinosaurs, particularly Tyrannosaurus rex. So over time, we've had to change our conception of dinosaurs, and it's been very difficult to do. We thought that they were big, sluggish lizards, not very bright, kind of failed at conquering the planet since they were eliminated by an asteroid. But as it turns out, they didn't all die out. Some of them continued on. So we have to change our image of dinosaurs from scales to this: big, fuzzy birdozoids. I don't know about you, but I'm kind of disappointed. So all of this required that we reevaluate and re-examine the evidence before us. It's been hard to do, especially for me, because we really, we had such a strong conception of what they were, but we always have to change our ideas and our existing theories to match the evidence that's there. And this is a key part of science. Evolutionary thought evolves. We have to constantly adapt our thought according to the evidence that's before us. But it's not all doom and gloom. I mean, now we know that they evolved into birds. It means that the dinosaurs have never really left us. They're all around us as birds. They can be these beautiful birds like the hummingbirds and the birds of paradise, or the carmine bee-eater. So the next time that you see a pigeon or a tiny sparrow, or you see a small brown hen roosting on its little eggs, and you look into its cold, dead eyes, you need to realise that this thing comes from a Tyrannosaurus rex. God, I love science. But this is the challenge of science. But is it really that different from everyday life? Science is full of uncertainty, of re-examination and re-evaluation. Now, the story that I've told you about dinosaurs, what it describes to you is one method of finding things out. We have the fossils, we have the evidence, we examine those fossils, we relate what we know about existing living things, and we relate it to those fossils to understand where we came from and where living things came from. But another way of looking and another way of investigating is to come up with an idea. So I'm going to talk to you briefly about the Higgs boson. Well, I'm technically not allowed to call it a Higgs boson if I'm a real scientist, according to Rolf Hoyer, who's the head of CERN. But a new particle has been discovered. Now, how did we come to this point of discovering a new boson, a Higgs boson? Well, the idea that we've always wondered where we came from, and we've wondered where the universe comes from. So we also wanted to know what the universe is made of. The first people to come up with this idea that everything in the universe is made of atoms were the ancient Greeks and also philosophers in ancient India. And so the most famous person is Democritus in ancient Greece. This idea was revived in the 1800s by a man named John Dalton. He asked, where do we come from? What is everything made of? Let's say that there is a very fundamental, basic unit that is the basis of all matter. So people began to do experiments. They did some experiments to see, well, is that true? Does it exist? And over time, after many, many experiments, for example, Ernest Rutherford discovered that the atom is composed of a nucleus, James Chadwick showed that this nucleus is orbited by electrons. Great physicists like Werner Heisenberg, Erwin Schrödinger, and Wolfgang Pauli showed that we weren't really sure where the electrons were at any one time. We found that what happens at the most basic fundamental level is so bizarre that they had to invent a whole new physics for it called quantum mechanics. So this is a story of how we came to get to this point where we wanted to find out how matter has mass, which is why we built the Large Hadron Collider. And the Large Hadron Collider is a 27-kilometre particle accelerator. It speeds up particles to near the speed of light and basically smashes them against each other. It's got to be the best machine. But the point of telling you this is for you to realise that not only do you have to look at the evidence, you have to come up with ideas for how the world works as well. You can come up with them, but you do have to test them. And sometimes you get to build really awesome machines to do that with. So this year, basically, we started out in ancient Greece and we came to 2012 AD to find that there is a particle that actually gives matter mass. And that entire narrative, you have to hear that whole narrative to understand how we got here. But this is the nature of science, you see. Science is full of wonder and fascination and adventure, but it's also full of uncertainty. And this is the key thing that links us to the real world and to the everyday, this uncertainty. There's so many beautiful things to find out in this world. And science is our best means of finding it out. You know, we'll stay up late to watch a space shuttle. We'll build giant particle accelerators to find out what matter is made of. And what we gain from it is we get to see the beauty, the everyday beauty of the world. But most importantly, it teaches us to think. It broadens our minds and it challenges us to accept this uncertainty and this constant re-evaluation. So it's a wonderful journey. I hope you'll come with us. Thank you.